Welcome to House of NIO. Let's talk about autonomous driving with two amazing guests. Yalcin Parlak, Head of Product Experience Assisted and Intelligent Driving at NIO Europe, and Beatrix Keim, Director at Center Automotive Research, and an industry expert with an impressive career at BMW and Volkswagen. Follow them for a global look at autonomous driving, from the competition to NIO's perspective on creating a safer, more efficient driving experience. Discover the latest advancements, regulatory challenges, and how NIO's NOP Plus is pushing the boundaries of what's possible. Welcome to House of NIO.
Welcome to House of NIO. First, I want to introduce our expert guest today. Beatrix, I'm happy to welcome you.
Thank you very much for inviting me to come to House of NIO. Thank you.
With all of your background, and this is quite several years, also in Volkswagen and also in BMW, what do you think is intelligent and safe driving in one of the key topics in the center of automotive discussions? What's your impression?
I think actually it is getting there. So far, it was very much about big cars, about electric vehicles, the EVs. But what is now really driving is not only the name of a software-defined vehicle, but really what is it good for? So it turns into all the topics around automated driving. A lot of people call it autonomous driving, but I think there is a lot of differentiation in between.
When people use the term automated driving, they have a certain understanding of what it is and what kind of benefit it can bring. At the same time, within this domain, there are different kinds of levels and functions, as you have mentioned before, which the people read about, speak about. Yeah. But when they think about it, they might still confuse what's behind that.
So there are level 0 to 5, right?
Correct. So the automotive industry is defining it actually in 6 different levels of automation. And to make it very simple, you can split it into main 2 areas, which is referenced by the responsibilities, meaning level 0, 1, 2, the driver is completely responsible. Mm-hmm. Level 3, 4, 5, the service or the system provider is responsible for the functionalities. And the point is here that it is very crucial to know that there are conditions that need to be fulfilled in order to have this level 3, 4, 5 functionality, because it is also very important to, pay attention to these conditions to create the user experience. Because if you have certain conditions where the functionality will not work, then you might also not create the experience you want to actually create.
But I think it goes actually one step back, right? It is why the whole system and topic of automated driving now became so important. I think actually, and please correct me if I'm wrong, it came pretty much out of the commercial vehicles, so the trucks, because now more and more we have problems on finding drivers, especially I'd say here in Europe. And it's, of course, a safety issue, right? We have so many accidents with truck drivers that they are too tired. And this is, of course, one of the big problems.
Absolutely. And what is very interesting is, as you've mentioned, there is in the commercial segment a lot of, let's say, interest in making the trucks more safe. But it is not only about safety, but also efficiency in the truck segment. But at the same time, what you want to create is you want to reduce fatalities, which is not only for truck segment very important, but also for the car segment. So one thing is, of course, always the safety. The second is also increasing the comfort and relieving stress, especially when a driver is stressful. He gets also distracted and then also might have an accident. And this is how we should also try to expand the support on the driver. I mean, also the homologation does its part on it. I mean, the GSR, which was recently launched in 24 in July, they also introduced new safety functionalities, which is also meant, according to the European Commission, to reduce fatalities.
You mean the regulation that there should be certain assistance systems in the car as of July in new cars?
Correct. In the new registered cars.
Yeah.
And this is what I like. I mean, the European Commission forecasts that those kind of new assisted functionalities, they can save 25,000 lives and reduce severe injuries of 140,000 lives. I mean, if we look at the data, you see that the increase of active safety and passive safety is also helping to not have a great increase in fatalities, although the number of vehicles on the road are increasing very drastically. So this is quite a success with the implementation of the new developments, that the accident rates can also get lower. When it comes to safety, actually NIO doesn't allow any compromise. That's also one of the reasons why we put all of our functionalities, all of our safety functions in all of our cars. So it doesn't matter if you pick the flagship EL8 or, for example, the mid-size premium sedan. All of them include the high-performing platform, including the architecture, including the sensors and the computers. From your perspective, do you think that that the overall global competition on AD systems are similar, or is it that the people expect in China different from the OEMs, or in Europe different?
I think this is very much the differentiation between the different approach to driving, the culture of driving, and of course, the expectation, as you just mentioned. In China, people are really on an individual mobility, that they drive a car by themselves. This is just a story of, let's say, the last 30 years. Before, it was very rare that people had a car, let's say, back in the 70s, in the 80s. So, but ever since the, let's say, mid 90s, this development became very, very fast, and more new models, new technologies were pretty much thrown at the people. And nowadays, the Chinese people are very much expecting innovation. So everything needs to be newer, the newest.
Yes.
And this is then as well that they're very open to technology innovation, to accept that. On the other side, out of the culture from, let's say, the system, people are not very much used to, let's say, data protection. That means as well that all the data you need for deep learning, for language models, this is very open available in China. While we in Europe, we do have a lot of protective rights about your data. And this then comes back into the overall safety approach. And of course, well, this is the kind of the country, especially, or the region where the car was invented. Of course, the process to make it faster was then done in the US. But we have a very long culture of driving and getting used to things. And I think, yes, sometimes we are still a little bit slow on these things. It's not that we're digital dinosaurs, but this is then, of course, the aspect of safety. And if you have, especially in the EU, you have 27 different states, different regulations, which are not yet unified. So to take a little bit of a slower approach sometimes needs to be the better one. In America, on the other side, it's a mix of both. So you have the very innovative approach. You have, of course, a very long driving culture as well. But the overall way how things are developing, as you just said, it is very open on testing. For us, for example, our patent law, you need to prove that you are the only one to have invented something, and only then the patent goes online, so it's valid, and only then you can start production. I think in China, you follow the American approach on patent law, that actually once you go into the institutions to say, I have developed a patent, I have developed something new, then it is already valid until somebody else proves you wrong. But it requires, you mentioned now already various times that it requires conditions and regulations. And this is where I see the difference in the big three regions like China, the US, and Europe, that obviously China and the US are much more open towards these new technologies, towards autonomous or automated driving, while in Europe we are lagging a little bit behind.
You've mentioned the homologation process, which is actually, as you have said, quite different. So you can simply say in EU, what is not permitted is also not allowed.
Right.
Whereas in US, for example, there is a so-called self-certification regime, which means you need to explain how your function works. You need to prove how it works and that it works safe, and then you get the approval. And the consequence is, as you've said, it is helping also to bring new innovations quicker to the road. On the other hand, in Europe, for example, you need to follow the type approval process, which means you have pretty much predefined regulations and predefined requirements which you need to go through to get the approval for your functionalities and then to launch that.
But where does the security and safety approach then come from with NIO? As I just explained by myself, that actually NIO or China is much more open to innovation and sometimes a little more taking a risk more than the risk-averse European. So where does that come from in Europe?
How I see it, actually, I also see a very great shift in what people expect from technology. So similar to their smartphone, especially I think in China that was the case, and then also I think recently that also increased a lot in Europe, they expect to have updates, not only just downloading a new app, but they want the support of their smartphone having more and more OS updates too. And they are also expecting that from the technology in their vehicle within the product lifecycle, especially when it comes to the premium brand cars. And I believe here, especially NIO is quite more than prepared with the software architecture and also with the hardware architecture what we're offering. I mentioned earlier that we have a very sophisticated sensor setup. We have also a very powerful technology platform which can deal with the data there. And that allows us to be also flexible in launching new overall over-the-air updates to the user that they can also, let's say, feel every day a new car. So it is similar like that. You are, an example what we have quite recently was that our users were saying that they want to have more support when they are changing lanes. And by the way, changing lanes is one of the key topics where accidents also can happen. So what they were saying is, yeah, we have a warning system, but actually they want to also see the camera view, how a car on the side is driving so that they can also prepare themselves better. So what we did was we used the already onboard camera system to then also show the blind spots to our users. So this update was then not done by requiring them to go to the workshop and get a software update, but actually get them over the air. So you get simply a notification on your phone, you download the software, and you have the next day the new functionality. And this we are doing not only like once in a while, but it is like quite frequently. And here I believe this trend, what we saw and what you explained earlier from China, also swapping to us, meaning that Europe also expects that from technology, and especially when it comes to premium brand. And in my honest opinion, I don't even think that this is something which should be only for premium brands, but also should go for the lower segments, especially when we are talking about safety functionality. Because if we're speaking about reducing accidents and reducing fatalities, then we should everything and anything what we can do to provide those updates to our users too.
I mean, especially as in the mid section, the mid segment overall in the automotive world is actually the majority. It's not only the premium cars, right? So I think that would be really helpful. But that leads me to the point you were mentioning, the OS, the operating system in the car. That runs, of course, this is one of the most important features now in all the newer cars, the software-defined vehicle. It runs on the not on the internet, but it requires the GPU, so the graphic card process unit, and it requires the chips. So when I come into, we had 3 years ago, we had the big chip crisis. There were no chips available, cars were not able to be built. How is that then for NIO? Because it requires the more functions you have. You have how many cameras, you told me? 11 cameras plus the LiDAR sensor and certainly some more. It requires then a lot of computing power.
Yes.
So how do you manage that at current point of time? And what is happening? Because you just said there is more or less than probably daily a software update necessary. How does that go forward?
Yes. So for the sensor, just like that, we have actually in total 33 sensors.
Oh my God.
And we are actually also using a multimodal approach, which means we are combining the strength of different kinds of sensor types to make the awareness around the car as good as possible. So we are using cameras, as you have mentioned, 11. We are using radar and we are using a LiDAR. And the key reason is that there are certain benefits what one sensor can deliver and certain disadvantages. So for example, the camera is very good in detecting objects and classifying them. But since it is a passive sensor, it's relying on the light source from outside. So when it gets dark, then it gets problems. When it's, for example, blinded by the sun, it can get problems. When we have a radar system, for example, it is very good in detecting velocities and also distances. But when it comes to detecting the object edges or the heading of objects, it gets their problems. So that's why we integrate our LiDAR system into our system design so that we can mitigate the weaknesses of the other sensors, which leads to not only a redundant system, but also it leads to a much higher safety mechanism which you can deploy in the car. And as you have mentioned, there is a lot of data generated. It is, if you want to have a reference, I mean, we are having like 8 gigabyte per second data rates, which is comparable to the data rate of multiple raw 4K movies, by the way. And those data need to be processed by, as you said, the brain of the computer, the brain of the vehicle, which is the Adam supercomputer. We call it like that. And it includes 4 NVIDIA chips, 4 NVIDIA Orin chips. In a partnership with NVIDIA, we have integrated them. And in total, they have a computing power of 1,016 tera operations per second, which means it's 10 to the power of 15 operations per second, 1,000 trillion operations. And as you have said, of course, there might be some dependency on those kind of chips. So that's why we have also introduced in the NIO Day the new 5 nanometer AD chip, which is also addressing the topic of not only performance, but also it's addressing the topic of cooling and energy efficiency, especially when you're talking about integrating new AI models and end-to-end models, meaning artificial intelligence and going beyond machine learning. Then you need, of course, a system that can also cover and be, let's say, from the energy perspective, efficient, because especially in a smart EV, electric vehicle, every kilometer of range counts.
Yes.
And if the efficiency is, of course, managed by the software itself, it should be also managed by the hardware. So the hardware needs to also work very efficient. So that's how we try to balance. And we also see it that those kind of trend will come, that we need to also increase the capabilities of the vehicle, because those kind of new technologies and new software will also have this higher demand on the architecture.
So can you see that NIO is not really going into to clear off the driver, so the fun of driving? It is not like there is somebody, let's say a traffic psychologist, who says that the last driver or the last person to have a driving license has already been born, so that we do not drive anymore. This is not the meaning of NIO, so it rather goes into still be with the car and using the car?
The key purpose, I think, what we have is to reduce accidents and to relieve the stress of the driver. So it also accounts to, if we can give time back to the driver, that is something what we of course want to do. But at the same time, it doesn't mean we want to get rid of the driver. Me personally, I love driving. So there are, of course, sections or areas where I enjoy a lot using assisted driving functionalities, and where I could also think about getting help, especially when it is very monotonous. But if you're thinking about driving in your ET5 in a country road where you have mountains, for example, I think that is something what I enjoy personally also. I believe also we need to listen to our users, and if we are doing those kind of research, we never see that people are asking to not drive anymore. I mean, in that case, they could also just take a taxi, for example.
Right.
But at the same time, of course, we need to make sure that the technology we have, that we can integrate it into the user journey as smooth as possible, that they can enjoy it tailored to their needs, and not just because the technology is there, we just throw it at them.
As much as in Germany, there are quite a lot of restrictions to go beyond, let's say, L2++ or L3. So what is the outlook for NIO? Where do you go, and in what time can we expect to get perhaps a real autonomous driving?
So that's a really good question, because actually we are showcasing in China very often what kind of capabilities we have already. And the limitations that we are not bringing this to Europe is partly, of course, the homologation, what we have earlier discussed, but also the strong dedication that we want to tailor the experience to our European use cases. The driving behavior and also the habits in China are completely different than in Europe.
Right.
So what we have already launched, for example, is the NOP Plus functionality in China.
What is that?
So this is the short term, and some listeners might already know that because they are very active in researching. It is the function navigate on pilot, which is basically a major milestone, a major step in increasing the driving comfort and also the driving efficiency. What it does, it combines different experiences together. In that case, it is combining the navigation with the driver assistance system. So basically, the user has to just activate a functionality. The car will then not only keep the right distance and also take, for example, traffic speed signs into account, but it will also have reactions context-based. Meaning, when your car is, let's say, centering in the lane and you have another car in front of you which drives slower, then it will overtake this car and then follow the traffic law by changing lanes again in front. So it will also follow your navigation destination. So for example, if you are about to exit a highway, it will take the necessary maneuvers for you to reach the right lane and then comfortably also exit the highway. And actually, this is something which is not only limited to highway in China. We're already having this function rolled out in urban and city areas where it goes one step ahead. And I think many people also in Europe dream of this functionality, that you have not only the reaction to traffic lights, but it's also able to help you in more complex scenarios, such as intersections when you're turning. Another, by the way, great case where you have a lot of accidents when you're turning right or turning left, where the function can support you. And the good news is that in Europe, we see a very great progress in also bringing the new homologational requirements to life, that we can also roll out those kind of system-initiated maneuvers, which I was talking about regarding automated lane changes, where the driver doesn't have to confirm or where the driver doesn't have to initiate them, but the car does it for you, which is a great step in also having a much, let's say, smoother experience when using the functionalities.
So I think especially a market like China, which is already for a very long time the biggest car market in the world. And when I read that, I think pretty much 70% or 77% of the cars in China currently running are already on more or less assistant driver systems. So there is a lot of learning on the data, right? And as we initially said, that in China, the data is quite openly available. So that means as well that China will be very much on the forefront of these developments. Before, it was a company here in Germany, which was very much leading always the way in safety functions. But it seems that now in China, this is much more the case.
I need to say, I mean, we are actually, from the pace perspective, really, really fast. And also what you have described, that we are, I would say we are very brave and we are very moving forward in trying new things. And we have already upgraded our emergency braking function in China to this end-to-end model, which is using AI models. And basically what is capable of, first results show that they can cover 6.7 times more scenarios and avoiding collisions than a standard emergency braking functionality. And as you have said, it's right, the amount of data is very necessary. So you need to teach the systems by providing good cases, but you also need to teach the system with actual accidents. And that's what we also use. So we have a very deep integration into our architecture. So we understand our data very, very well. And the strong positive side also is of our user community, that they are also willing to contribute because they want to have safer cars. I mean, if they are saying, look, I have a certain problem in my car, and you know what, I want to make that never happen again, I am willing to also contribute my voice. For example, when what we have launched just now in Europe is also the one-click report. So the user can press one button, and what the car will do is it will ask the user, what's your problem right now? Do you want to share your feedback? Basically, this is what Nomi will do, our in-car AI companion, which also has proven itself to be a very strong feedback channel. So the driver has then the possibility to speak to Nomi, tell about the problem, what he encountered, and it can be even just a fresh idea what the user just had. And on top, we will also be able to collect the data, what happened, and then analyze the problem and use it for training our models. And this is something what you have already said. I mean, in China, commodity, they're doing that like quite often, quite frequent.
And how do you get the feedback here in Europe? What is your experience? Are the European users as open to share?
I need to say there are differences between the 5 countries where we have already launched. And in total, I would say the community we have, we are very lucky with them. So they are not only participating voluntarily in the user advisory boards, which is a board of people who just come together. They are owner of cars and they are willing to share and come to workshops with us together. But also they are really open in the app, and they are also very often, I mean, you just come to the NIO house and you visit a person who has already a car, and he's totally willing to share whatever he thinks or whatever is in his mind. Because our philosophy is that whenever we launch a new functionality, we also want to integrate the user into the whole loop, into the whole process. So that means we are somehow even doing co-creation with them. We are doing a lot of research with them together. And my experience is, especially people in Norway, in Netherlands, and also in Germany, they are, I mean, we might think that they are quite close, but actually they are also very open. I'm not sure if it's because they are already owning a NIO and quite open-minded, but we are actually very lucky with our user community. How do you think is it in China? Is it more open?
I think, yes, they are much more open to share and to support as well. I think it is very much as well a very proud thing that a company like NIO was taking up so much and is so well regarded and so much at the forefront of technology that people like to promote and to push and to really support this. But let me ask you one stingy question, because we're talking about the data. And I always say where there is a bit, there is a hacker. And now we have all these cars which are pretty much driven only by data. Isn't that a bigger risk then for a break, that the car is hacked? What is happening here?
That's a concern, of course, what people might have, especially when they're not very familiar with NIO, especially when they hear, it's a Chinese brand and maybe they're also not really safe. But actually, it's the opposite. I mean, especially those new technologies, of course, they need to have a lot of knowledge and experience in how you protect the data. And one thing is, of course, to fulfill all the regulations, but also another thing is to have also best practices. So what we are doing, of course, we are fulfilling all of those R155, R156, which are
What is
the
that?
cybersecurity and software update management system requirements, what you have in Europe. So there are certain regulations which you anyway have to fulfill, which protects your data. And that is not only about that someone cannot hack it, but it is also about documenting in a very specific manner what is in your car, what you have changed for the next software update, and what is going to happen in the future with the software if this and that change gonna happen. So we are fulfilling and let's say also compliant with all of the regulations and automotive standards to make the drive as safe and as protected as possible.
Question back to you. Do you think that an AI and artificial intelligence can differentiate between a Chinese, a Japanese, a German, an American driver?
We were thinking a lot about how and if AI should personalize in the driving behavior, depending not actually on the country of origin, but even between different people within a country, there might be a difference in how they are driving. So the question was, should we maybe define that the driver assistance function should, let's say, learn from the driving behavior and then also act the same way? The driver needs to have a system that is predictable and that the driver can trust. Because I'm not sure if you have felt that. If I'm driving with a taxi driver and he drives a little bit more aggressive, I feel a little bit nervous.
True.
If I'm driving myself, I'm feeling quite okay if I drive a little more aggressive through the curves. So that's why I think for especially intelligent driving, a combination with AI, the masterpiece is always that it is safe and gives you a reliable functionality that you can predict. So it means, and this is, I believe, something what we should also leverage even more, using AI to create a functionality that is not only uninterrupted, but also driving like a human is is a task that we actually should really try to fulfill, because the more human-like a car can drive, the more the person can also rely on it and also feel comfortable. So the main purpose again is you want to drive safe. So that's why you shouldn't maybe drive too aggressive. So you want to also be predictable, and you shouldn't, let's say, surprise the user with different kind of driving habits happening here and there, because a normal driver, he can be a little bit aggressive in certain areas or certain times, and he can be also more smooth in certain times. Depends also on the mood. And now the question is, should an AI do this or not? In my personal opinion, the focus is more on the comfort, on the safety. What do you think? Do you think it's better that the car should learn how you're driving and then adapt to it?
I think it is, we have too many road accidents in any country. I think actually one accident and with a lethal outcome is one too many. So the whole thought behind telematics and autonomous driving is to reduce accidents, right? But on the other side, it shouldn't become boring. So the pleasure of driving should still be there. Should it be? I don't know. Perhaps this is something very German that we are looking into this. But I know that in China, people love driving the same way. So enjoy the cars. And this is why they're choosing different kinds of models. So I think it's the middle way. On one hand side, the car should adapt perhaps to the driver's way, but of course in a responsible driving way.
I mean, you're nailing it. I think what we also need to think about is how we can enhance the use cases and how we can enhance also the operational design domains, how and where we can support the driver.
Yeah, I think sometimes a lot of people don't really know what LiDAR is and where it sits. So it's on the NIO cars, you can always see it's the little humps in front of the roof. LiDAR seems to be really a very driving topic, not only out there in the world in technology. I remember the car shows where it was always propagated. So as well for NIO. So why is LiDAR so important for NIO?
LiDAR is a very sophisticated technology to support the situation awareness of the car. So LiDAR stands for light detection and ranging, which means that this device, which is basically forming the watchtower of our car, meaning the position is quite high and the view of the scenario will be very good. This device is sending out laser light in a very optimum wavelength, which is perfect also for bad weather. So what happens is the laser light is sent and then reflected by objects, similar as it is done by radar, for example. And by this, the car is able to create a 3D dot cloud to enhance the situation awareness, which means we are combining the strength of the LiDAR to mitigate the disadvantages of, for example, a camera or radar. So in total, that means we can not only increase the redundancy in the car because we have a multimodal sensor setup, but we are also able to increase the safety mechanisms in our car. So it means we have one more device to rely on when it comes to taking decisions. So as I said before, we have, for example, tested a heavy rain scenario where you are approaching a traffic jam on highway. So imagine yourself, you're having a car in front of you and it is heavy raining. And suddenly the car in front of you cuts out, leaving you behind a stationary car. And now you need to be very fast in braking. And what we have seen in the comparison, our LiDAR system was able to detect the car in front earlier than a car without a LiDAR system being not able to avoid the collision. However, our car was able to react to it because and thanks to the LiDAR system.
So the car put the brake in automatically.
Exactly.
Okay.
So what we are using is this LiDAR system is not only used for driving functionalities, but we also use it for safety functionalities such as the emergency braking function.
If I remember back on systems like ABS or ESP, which were invented by one manufacturer, and initially were very expensive. It was an additional option you could book in. But then through the course of time, nowadays, ABS, ESP, airbags, these are serial equipment which are always expected to be in a car, like a hygienic factor. It needs to be there. So do you think LiDAR will be something like that as well?
If you would ask me, they should have this kind of safety mechanisms too. And what we are seeing is also that we are learning from this and even introducing more LiDARs to the side of the vehicle in our ET9. As you have watched maybe the introduction from our founder, William Li, we have launched the new luxurious sedan where we add also two more LiDARs on the side of the vehicle to cover more scenarios and more use cases. And the good thing is, what we see is that this technology and also the capability of the car can then also match with the increasing demand of use cases. So, and combined with the new introduction of our 5 nanometer AD chip, we are also prepared already for the data hungry AI models, which are set to increase the safety even more. Because all of what we are doing actually is meant for the purpose of improving the safety and also to fulfill the vision of our founder, which is actually 0, 0, 100. 100% smart electric vehicles on the road, 0% emission across the whole life cycle, and thanks to intelligent driving systems, 0 accidents and saving lives.
Well, I think that is a very anthroposophic approach of William Li. And overall, I dare say I do look forward to the future development of NIO, of the products. Quite excited to get then a drive in the ET9.
I hope you will have the chance soon to also drive one yourself. It was a great pleasure talking to you. I learned a lot from your insights. Thanks a lot, Bea.
Thank you a lot for your presentations and your explanations, especially. Thank you for having me.
Thank you.
From the LiDAR to the impact of AI and user-driven innovation, that was a fascinating discussion on autonomous driving. Thanks to Beatrix and Yalcin for their insights, and see you next time on House of NIO.